Okay, so a couple of things I want to explain before we get to the lesson. So again, you have a Delta Math assignment today. On your worksheet, pay attention to what you're doing because you're not doing all of the problems. When you ask me what you're supposed to do, you know what my answer always is, what'd you write on your calendar? So you better write it down and figure it out because I'm going to tell you. On the Delta Math, though, when it's due on the 12th, it is due by the time the tardy bell rings on the 12th, whether you're here or not. The only time you get extra time on Delta Math is if you were absent the day it's assigned because you missed the lesson, okay? And I think I said yesterday, but I'm not sure. If you are absent the day something is assigned and you get an additional day, you should still be able to see it. When you do it, it'll probably tell you that you're late and it'll probably give you a 0, but I can go in there and fix that, okay? It just keeps me from having to reassign it. I want to show you something on Delta Math real quick, and then, all right, so if, I don't know that this question necessarily warrants this, but if you have to put in more than one answer, like the answer isn't just 2, it's 2 and 4. When I was working through this, because I worked through all of these before I actually assigned them, and I went to put in, I had like 2 answers to put in here, so I used the little squiggly brackets, and then it said, don't use the squiggly brackets here, use the plus and minus sign. So that's this right here. So I want to show you, if you have more than one answer to put in, because it's a set of numbers, you use the little plus sign, and then it makes a set for you. Okay? And if you made too many, but there's only 2, then you do minus, and then it's there for you. Okay? Does that make sense? And then you put your stuff in there. Okay? So just want to let you know what that's what that means. Go ahead. Yeah, so there's no plus or minus option if that's what you're asking. Right, yeah. You have to put them separate when you listen. It should be from least to greatest. Whether or not it would count it wrong if it's greatest to least, I have no idea. I didn't test that part out. I didn't think about doing that. Okay. But on this one now, you don't have 2 shots each time, because on the other ones you had two chances before you officially got it wrong. So you've got to, you do it, and then if it's wrong, then it's going to knock you back to 0. Okay. But there's just a couple of problems in each section. So there's like 4 sections, but I think the most there's in each section is 3 problems. Okay. All right. So I just want to make sure you understood that. Then let's go. Oops, I did not turn this off. Let me take care of that real quick. Okay, now this is going on page 72 when we are done. So yesterday we were solving exponentials. Today we are solving logs. And I just remembered there was one more thing I was going to say about your calendar. I better do it so I don't forget at the end. You have quizzes Monday and Tuesday if you want to write those on your calendar. On Monday, your quiz is over 3.1 and 3.6. That's the graphing of exponentials and graphing of logs. And then on Tuesday, you have a quiz over 3.4 and 3.5. Which is the beginning stuff on logs. All right. Okay. So you're good. So if you want to write that down real quick, I'll let you. So remember this, the calendar will always be available on Google Classroom as well. We're good? All right. So now we're going to solve logs, and the first type of situation we can come across is where a log equals a log. And so we condense the logarithms on each side, so you just have one log on each side. Then you use the one-to-one property. The log one-to-one property says if log base b of x equals log base b of y, then what? X equals y. Okay. And then it says solve and check for extraneous solutions. This part we weren't doing with exponentials, but you have to do with logs. Okay? So let's think about this. This is why you need to be able to picture these parent functions in your head. For an exponential function, what's the domain? Exactly. Negative infinity to a positive infinity. For a log function, what is the domain? 0 to infinity, right? Because your log functions, the parent functions, look basically like this. So that means that if log base whatever of x is going to graph to look like this, then do I get to take the log of 0? No. Do I get to take the log of a negative number? No. So if I get answers that would then cause me to be taking the log of a 0 or of a negative number, then they're extraneous solutions and I don't get to use them. Okay? So we have to check for them. And you don't have to actually find the exact value. We'll talk about how we estimate and whatnot. So let's start with number 2. You have to condense log equals log, which is what we have. So now I can use the one-to-one property, and this gives me k squared minus 4k equals k plus 14. Right? Yes, exactly. They would have to have the same base. And then, so now I just solve a quadratic. So I get k squared minus 5k minus 14 equals 0. Then I factor. Be k and k, so then that would be minus 7 and plus 2. You agree with that? So then my answer is k equals negative 2 and 7. So, but before I get all excited and box that answer, they may not both work. And I checked both of them. It's not like you just check a negative. It's not that all your negative answers don't work. It's when you substitute it back in what happens. So if I substitute the positive one back in, well, clearly that's going to be fine. If I substitute it in here, it's going to give me 49 minus 28. That's a positive number, right? So I'm good with that one. So this negative 2, here gives me negative 12. I'm good. Negative 2 squared is going to be 4, right? Negative 4 times negative 2 is what? 8. So is this one going to work? Yes, because I get 12. Because 4 plus 8 is 12. Okay, then that's probably going to be true. It would just be that one of them doesn't work. Maybe not both of them. So then we write that we have an extraneous solution. We'll get there. No, it doesn't have to work for both of them. No. Right, separately. And see, does 7 work? Yes. Does negative 2 work? Yes. So then there are my answers. No. Oh, you mean for one of them up here? Oh, I'm sorry. No, it just has to not work in one of them. Like, just because I can take the log when I substituted in here, that doesn't matter, because if I can't take the log over there, I thought you meant when you said meant both of them, you meant both of these. So it just has to not work in one of them. Okay. Then it's extraneous. Yes, very good. Okay. We good? Sorry, I misunderstood the question at first. All right, number 3. So we have log of 4 plus log base 6 of c plus 3 equals log of 8. So I'm supposed to condense first and get 1 log on each side. Can I condense on the left-hand side? No, because those bases don't match, right? If I moved it over and I condensed on the right side, okay, great, but then I still don't have the bases that match, and so I'm not going to be able to do anything with it, right? So if that happens, then I can move some stuff over and I can condense, but I still wouldn't be able to solve it. This is actually a typo, but it makes good for, just discussion that if that did happen, I couldn't do it. So we're going to just pretend like that 6 isn't there. You don't get to magically pretend like stuff isn't there, by the way, only if I tell you. There's no special thing to that. So now I can condense on the left-hand side. When I add 2 logs with the same base, what do? It turns into 1 log that I do what with? Multiply. So it's log of 4 times c plus 3 equals the log of 8. Now I have a single log on each side that has the same base. I can use the 1-to-1 property, and I'm going to go ahead and distribute as I do this. This gives me 4c plus 12 equals 8. So 4c equals negative 4. c equals negative 1. And they're all in set notation because they're all sets of answers for graphs. So when I substitute negative 1, well, negative 1 plus 3 is a positive number, so it works, and I'm good. Everybody okay with that? Yes, sir. Well, it would just be like you might be able to simplify it some, but you wouldn't be able to solve it. Yeah. All right, so then let's look at number 4. If I have 2 logs with the same base and I'm subtracting, I turn that into a single log that has what? Division. So this is log base 7 of w plus 6 over 5w minus 3. And that's equal to, what happens with this 1/3? Comes an exponent, right? So then I get log base 7 of 8 to the 1/3 power. So now I have a single log on both sides. I can use the 1-to-1 property, and this gives me w plus 6 over 5w minus 3 equals, and I can go ahead and simplify that. What's 8 to the 1/3 power? 2. So then I multiply both sides because I need to solve for w, right? So I get w plus 6 equals, and when I multiply, I'm going to go ahead and distribute. That gives me 10w minus 6. Make sure you distribute correctly. If you need to put 2 with parentheses first, you can do that. But then this is going to give me 9w over here, negative 12 over here. W equals, positive 12. Duh. W equals 4/3. All right, so then we check our answer, right? Putting it into the positive one, obviously it's going to stay positive. So 4/3 times 5 is going to be 20/3, so that's a little less than 7. Minus 3 would still be positive, so I'm good, and it works. What questions do you have? You good? All right. Number 5. Do number 5 on your own. Do number 5. Remember, we have to be able to factor quickly and accurately. All right, so then when I go to try these out, well, if I do the positive one, obviously the positive is going to be fine in both of them. The negative one, when I take a negative number to an even exponent, that's all going to end up positive there. That's fine. And then negative 1/2 times 4 is negative 2 plus 3, so that's going to stay positive. So good, and that's my answer. Everybody good with that? Okay, good. All right, now you do number 6. Huh? You're official. Okay. He even talks to himself sarcastically. Isn't that funny? Oh, mocking me. I wasn't even sarcastic to you when I said it. I was nice about it. And then you're being all, no. Okay. Yes, so the discussion they're having over there, if you can't hear, is that when you have this, you have 2 options on how you could go about it. That is the cube root of 16 squared. No, I'm sorry. It's the square root of, it is the square root of 16 cubed. Do you have to cube 16? No, you can take the square root first. That's what you can. You can cube 16 and take the square root if you want to, but I wouldn't want to do that. You can take the square root and get 4 and then do 4 cubed, which is going to give you what? 64. Okay. Then this gives me a squared plus 2a minus 63 equals 0. Okay, so I want to make a point here that I want to make sure we all get, because I had to correct somebody and they didn't like what I had to say, but it really didn't matter because, like, do you want to get credit or not? I mean, that's what it boils down to. You have to, in order to use the one-to-one property, you have to have one log on each side, and then the next thing you have to have is this part of the log equals this part. It's fine to simplify that, like into that, because it's still the same thing. But you cannot skip this step. Even though you know it's going to be 64 and you're going to subtract, if you jump from here to here, you did not use the one-to-one property. I think they had also done it on another one. I don't remember which one they did it on. But either way, just make sure that you're actually using that one-to-one property. All right, so then we factor, and then I was asked last period if you could use the quadratic formula. Sure, knock yourself out. I wouldn't do it here, but whatever, it's fine with me. It's not wrong, it's just, to me, way harder. So, but I think the problem was we didn't know our multiplication facts, so I'm just saying, we don't know multiplication facts. So you get a is equal to -9 and 7, right? So the positive one's usually the easiest one to check and check first. So when I substitute it in up here, obviously it's going to stay positive, right? And I'm not substituting it into those. But then -9, when I substitute it in there, I get -8. Do I get to take the natural log of -8? No, I do not. So we're going to mark that this one is extraneous. And then our actual answer is just 7. So I want your extraneous answers marked, because I want to know that you actually found it and that you solved it correctly. Like you got that number, but then it doesn't get used. Okay, we good? Yeah, you can just put the arrow and just like abbreviate extraneous. That's good enough for me. You cannot take the log of a negative number. No. All right. So, and one more thing about just this situation in general, when the condensing stuff, one of the things that I saw from a lot of people was taking the 3/2 and putting it as an exponent on these parentheses. You can't do that. This is not a log. This is a parentheses with 2 logs in it. So you have to condense the inside first with that hanging out there. Then it gets to become an exponent, right? So just be careful with that. All right, so let's flip it over. So now we're going to solve logs when you have a log equals a number instead of a log equals a log. So you still condense as much as you can and isolate it, which means it has to be all by itself. Then we rewrite it in exponential form, and then we solve, and again, check for extraneous solutions. Anytime you solve a log, you have to check for extraneous solutions. All right, so we're going to start with let's start with number 7. So this is already a single log equals a number, right? That's awesome. So we can just rewrite it as an exponential. We will take 2 to the 7th power equals 3x minus 4. What is 2 to the 7th power? 64 times 2, which is 128. Ooh, I can't even write the number correctly. 128, I forgot the 2. Equals 3x minus 4. So I get 132 equals 3x. X equals 44. All right, so when I substitute that back in, 44 times 3 minus 4 is definitely going to be positive, so I'm good. Easy enough. Are you making up stuff? All right, so let's look at number 8. I have a single log equals a number, right? What is the base here? E. So I'm going to take e to the 9th power equals 2 times a. Do you know what e to the 9th power is? No. Do I substitute in 2.7? No. And we don't have a calculator. I don't want to just leave this. It's going to stay e to the 9th, but I still have to solve for a, so what do? Divide by 2. So I get e to the 9th divided by 2 equals a. So then I still have to check my answer, which may require me to kind of estimate in my head a little bit. But is this going to be a positive number? And when I double, is it still positive? Yes, so that's good. It works. As long as whatever you're taking the log of is positive, you're good. Okay, glad you agree. All right, let's look at number 10. So on number 10 here, I've got to isolate the log, so what should be the first thing I do? Good. Get the 4 on the other side. So I'm going to get 2 times log base 9 of k squared plus 2k equals 1. Right? Now that 2, can it become an exponent on that log? Yeah, do you want it to? Do we have another option? Yes, I think the other option is way better. Instead of squaring this, can't I just divide both sides by 2? Yes. So I get log base 9 of k squared plus 2k, and those parentheses are very important, equals 1/2. That's way better than squaring that binomial, right? And now I can rewrite it as an exponential, so I get 9 to the 1/2 power equals k squared plus 2k. Yeah, so that's actually 3. So then when I set it equal to 0, bless you, we get k squared plus 2k, bless you, minus 3. Then I can factor. Notice I've got equals, 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 equals on every single step that I have. You get k plus 3 and k minus 1. So k is negative 3 and 1. So the positive 1, clearly, it's going to work just fine. The negative 3, well, negative 3 squared is 9. It'd be 9 minus 6, so are we good? Yes. What if this was k squared plus 3k? Then it would be 0, and that would not be okay, and it'd be extraneous. But what we have now is good. There's an asymptote. Exactly. But the transformation is taking place in here. That's why we're substituting it back in. That's why we don't just knock out the negative numbers, period. It's what are we actually taking the log of. So you're kind of bringing it back down to just the parent function part of it. That's a good question, though. All right, so let's look at number 11. So I have 2 logs of the same base that are being added. So I get to change that to a single log where I do what? Multiply. So this is 2v plus 3 times 2v minus 3 equals 2. So now I have a single log equals a number. I can rewrite it as 4 squared equals, is this a special case of any kind? Yes. So 4 squared minus 9. Oh, 4 squared. Oh, my goodness. 4v, I know, I'm making stuff up. I'm sorry. That makes no sense. 4v squared minus 9. There we go. And then 4 squared is 16, so I would subtract it, so I can set this equal to 0. So what's negative 9 minus 16? Negative 25, okay? Now, is that a special case of any kind? Yes. So this is 0 equals 2v plus 5, 2v minus 5. So v is equal to plus or minus 5 halves. Still fine for you to write it like that, just as like Jenny said earlier, in delta math, you would have to separate them out if that's your answer. All right, so now we have to check them. Check the positive 5 halves. Well, 5 halves times 2 is 5 minus 3. I'm good. 5 halves, well, positive will stay positive. We're good. So negative 5 halves, we'll get negative 5 minus 3. Is that going to work? No. So the negative part here, this is my extraneous. Right? So my actual answer then is just positive 5 halves. Ugh. Where did I lose you? To get here? I subtracted it from both sides so I could set it equal to 0. Where did it come from, or where did I go from that? It would be 4 to the 2nd power equals this. That's what I did. Okay, good. All right, y'all do number 12. What are you trying to move? Right, exactly. I could, if it was, yes, you're right. Were you trying to multiply both sides by 3? Yeah. So, okay. Okay. Well, no, it's not that it's a natural log. It's that, like, from right here, if you're trying to start by multiplying both sides by 3, you basically have to multiply everything by 3. So you'd have to multiply this by 3 also, which would just be weird. So this 1/3 isn't on the whole side. Like if this wasn't there and we just had that part, then we could do that. But yeah. Okay. So that's, and I mean, you might have written that step a little bit differently, but that's what's happening there. Then what's 27 to the 1/3 power? 3. Okay. So at this point, even I have a single log equal to a number. So I could go ahead and rewrite it now, and I could write e to the 4th equals, and then I could simplify this as I take it out. So this will be 3 times x minus 5, which will give me 3x minus 15. Then I'll add 15 and divide by 3. So x will equal e to the 4th plus 15 divided by 3. Do what? Check for extraneous solution. Oh, yeah, no, it's 4 plus 15. All right, so then when I substitute that in, well, I basically have to know if it's bigger than 5 or not. And we do not have to type it, you don't have to get a calculator, you can estimate. So E is about 2.7, right? If I estimate it with 2, that's going to be a low estimate. But if it works with 2, would it work with 2.7? Okay, so what's 2 to the 4th? Good point, yes. Okay, very good. But I also want to make sure you know how to substitute if that doesn't happen. But he's right. 15 divided by 3 is 5. And so this is clearly a positive number. It's obviously going to be bigger than 5. But let's say that that part wasn't there. We need to look. If I do 2 to the 4th, that's 16, right? 16 plus 15 is 31. So that's 31 divided by 3. That's a little bit more than 10, so we're good. It's more than 5, okay? So you can use a rough estimate. You don't have to actually multiply out 2.7, okay? You could be able to estimate it good. So this works, and we're good. All right, look at, or you do 13. Good. Me too. Yeah, most people do. Okay, let me just point this out since we're hating on surface area and volume and stuff. Let me not remind you, but tell you, I have it does, because I had a calculus student sitting in the back of my room second period the other day, and I walked over there and looked at what she was doing, and I was like, what? You're doing geometry and calculus? What? You have to know your volume formulas? You have to know how to do surface area without a formula chart? What? Yeah, so I wasn't lying to you. Like, you really have to know that stuff. You got to know circles like nobody's business, okay? You got to know that stuff. Hopefully you didn't throw away your ISN. All right.
I gave it to you, so I hope you didn't throw it away.
If you think I'm giving it back to you, it's not happening if you gave it to me. All right. So do that when we get here. Do both of these work? No. The -5, when you substitute it in there, you get -4, so it's not going to work. So this one is extraneous, which means, but 7 works. They might both be extraneous. So you got to check them both. 7 works. Even if it's a positive number, it is possible that it will be extraneous. I know that hasn't happened here, but it is definitely a possibility. So, ooh, that's an M. N equals 7, and this is your actual answer. Okay? There'd be no solution. Empty set. Yeah. You can have it like that, or it could be like, and literally the empty set with the squigglies. There's two different ways to do it. So. All right. Number 14. Let's do this one together. So if I have two logs, with the same base, and they're subtracting, I condense them and get log base 2. What do I do with these? Divide. So I get c squared over 3c minus 5 equals 2, right? Then to rewrite this as an exponential, I will get 2 squared equals c squared over 3c minus 5. Then what do I do to get this solved? Multiply by 3c minus 5 and make sure I distribute that 4 that's on the left. So this will give me 12c minus 20 equals c squared. I'll let you go ahead and you finish that up while I hand out the assignment. You didn't need my help with it anyway. Did you finish it? Y'all are putting stuff up. Finish it. I believe Rio. Gotta say, Michael, let me see it. Did you finish it? You were lying to my face, son. Get that back out. Good. I know you didn't even do it. Get it back out and do it. All right. Do both of these work? Yes. When you square them, they're positive no matter what, and we are good. That is our answer. All right. What questions do you have? Anything? Awesome.